Okay, so I'm just trying out something here. Instead of the usual game that I would otherwise stream, I'm going to do a bit of a network analysis on some political tweets from Biden, from Trump, from AOC, and from Bernie Sanders. And while we're doing it, let's listen to a bit of a Soviet wave over here. It's probably obscure enough so that we don't get copyright flagged on Facebook. And so I began gathering the tweets already. It's taking a bit of a while though. I have here, just cancel this. Okay. All right. So I have here a tool. It's an Excel plugin called Node Excel, and it is used for network analysis. Over the past couple years, a lot of my work at the agency has focused heavily on network analysis as a way of surfacing insights from text data mainly. So because we started out as a PR agency, we are mainly concerned with text data. So that's what I'm looking at most of the time with network analysis. And I figured a good way to spend a Friday night would be to use that to analyze some tweets. Starting with Donald Trump here. So using this tool, you have the option here of importing data from Twitter. So you just need to connect it to your Twitter account, and then you can begin gathering tweets. So I set it to gather the 3,200 most recent tweets of Donald Trump. And I'm going to do the same for AOC and Biden and Sanders and whoever else really. Well, we could gather the tweets of whoever celebrity we want, whoever. So it's a good way of figuring out what these people are saying and then find trends in that. All right. Now, when you import the tweets, it'll populate the page like this. And then this is going to sound super nerdy, so please bear with me. Whoever is out there listening, I don't know why you would be watching this on a Friday night, but here we are. Anyway, so you have a bunch of different information about the tweets. You have the content of the tweets themselves, and this is what we will be analyzing. So we'll do a bit of content analysis here, try to figure out the different themes and narratives and topics that Trump has tweeted about. And there's a lot of data here, and most of it we probably will not use for this exercise. What I really just want is this tweets column over here, which contains the actual content of the tweets. So what I'm going to do is to copy over this column to a new file. And this new file will be my corpus of text that I will be analyzing using network analysis. Now, as it loads, there we go. Network analysis it's a methodology that's been around for a long time, maybe since the 40s or the 50s. And it's been used in a variety of different fields. It's been used in biology, in the social sciences. But more recently, it's also been applied to what are called semantic networks, which are networks of knowledge. So you could think of them as like webs of interconnected concepts and words and phrases. And that's basically what a corpus or a body of text is. It's a bunch of different words and phrases that through some logical way are related to one another. And what we're trying to uncover here are those relationships And by doing so, we can figure out what are the themes that have come to dominate the tweets of Mr. Trump, that guy everyone loves to hate. He's a terrible guy. We all hate him. All right. So we have this here. And I'm going to save this as Corpus Trump. There we go. And then I have this piece of open source software called Kowo. And this allows me to transform a body of text into a network. And that network is what we will analyze in a different piece of software a bit later on. So while that's happening, I'm going to start gathering the tweets for Bernie Sanders because, well, let's go with Biden because it's Biden who's going to go up against Trump in the coming elections. So here we go. Biden, Joe Biden. Let's start gathering Biden's tweets just so while we're working on Trump, this is going on in the background. Gathering 3,000 tweets of Trump took about 10 minutes, so I don't want to be just waiting around for Biden's tweets. Let's let it work while we do Trump. And then after all of this, we can compare Biden's narratives, Biden's, the themes he talked about, the words he used to discuss these different themes and subtopics. We can actually compare those with Trump and then sort of figure out how congruent are their narratives. Are they congruent in any way? Is there any overlap that might not be very apparent? We'll find out. So while that's happening, let's go into Kowo and then open up our corpus that we just created for Donald Trump. Now, here is where you set some options. I would like the network to contain, let's say, 500 words. So these will be the 500 most, you could say, statistically significant words in the sense that they came out the most and that they were the most important words that were used in that body of text in those 3,200 tweets. And then you want to weed out all of the words that don't carry much meaning to them. So this is why we use what is called a stop word list. And what this does is it will exclude all of the words that are in this list from the analysis. So they might be words like prepositions, of course. Those don't carry any meaning at all, so that you don't want to use them. And it could be any type of word that you feel will not be very insightful. So for this, there we go. So I have a stop words list here. And this is what it looks like if you're curious. Desktop, data shit. I really need to figure out a better way of organizing my folders. There's just a lot here. And that's what happens when you work with data every day. Okay, stop words. So this is my custom stop words list. And then as you can see, it's a pretty long list. I still keep adding to it pretty much every time I use it. And I have here a bunch of Tagalog words because I do analysis on local text as well from the Philippines. And then a lot of English words that don't really, words like through or that or neither. So those don't really contain a lot of meaning. And so we don't want them to be dirtying up our analysis. So that's why we use stop words. And then let's open up our text file for Trump. Where was that saved? It's probably saved in documents, was it? Yeah, Corpus Trump. That should be a CSV, so let me just save it as a CSV. I'll need to cancel this. Yeah, I need to cancel that. Let's save this as a CSV. It's pretty gnarly music. I like it. Makes me miss some of the events we used to go to before this whole pandemic. What was he going to do? Yeah, save as CSV. So let's choose CSV. Say yes. All right. Now let's select our CSV. Here we are. All right, then you just need to click on create map, give it a few seconds to work, and then it will spit out a network file, which we can then analyze. Okay, where is that? Here we are. So this is a GML file, and what I'm going to do is open that up in a piece of software called Gephi. Gephi is a network analysis tool. And before we start that up, I should probably talk a bit about what network analysis is. Where is it? There. So network analysis is a way of it's a way of organizing information so that they can be of interrelated pieces of information so that they can then be analyzed using different statistical methods. And at the very basic level, the way it works is you have a bunch of what are called nodes or vertices. And each of these nodes or vertices can represent a single thing. So they in a, let's say, a social network such as Facebook, one user would probably be one node. And then you have relationships with other people, your friends on Facebook. And then all put together, if you drew a map of all of those nodes, those different people and relationships between them, you would have a network. And over the years, people figured out how to represent different things as networks. So they have represented, different protein sequences, different things that people study in biology and the social sciences. Different things can be represented as networks. In the realm of semantic networks, people try to represent knowledge as networks. And so that's sort of what my deal here. I look at text, and text is itself a representation of knowledge or an expression of that. And so that's why I feel that this method would be useful as well, because after all, what you might call a story, which is a piece of text, is pretty much just a collection of concepts and the relationships between those concepts. So if you imagine that in that way, then you could also represent a text or a collection of text as a network. Okay, now let me just quickly start gathering Biden's tweets again while we do our work in Gephi. There, Joe Biden, let's gather your most recent 3,200 tweets. All right. This is super nerdy. Not the typical thing that people would stream. I hope it's coming out okay though. All right. So let's go into Gephi, and then we just loaded up our corpus of Trump tweets, and then we can see here in the data laboratory, which is like the Excel section of Gephi, that it has identified the most important words or phrases that Trump has used in those 3,200 tweets. And this was the work that Kowo did. So you can see here Up top, we have hoax, there's phony, COVID, employee, leadership, and so on and so forth. Joe Biden is in there as well. MAGA is in there. And then here on the edges sheet, you can see the relationships between each of these concepts. And then you can click on weight to see which ones had the most significant relationships. So they see here that public and rep, and then Trump and Biden had the strongest relationships in text. And that means that they were used alongside one another the most in all of those 3,200 tweets. So in order for us to make sense of this, we will need to do some layout work so that we can better visualize this graph and be able to analyze it. So usually you would start with just this black mass of dots like this, and obviously it's not very useful if that's the kind of thing that you're looking at. So what you want to do is to run a bunch of things over here, run a bunch of algorithms. The first thing that I like to do is to calculate network diameter. And what this does is it allows you to determine the importance of nodes in the network. So in our case, we will be able to determine the most important words, phrases, and concepts that were used by Trump in those 3,200 tweets. All right, now let's use a directed graph. I'm sort of going back and forth between using directed and undirected graphs for text. I tend to get better results overall with the statistics when I use directed graphs, and I've seen studies that have designated their own semantic networks as being directed networks, so I think it's fine. So let's stick with that for now. You can see here that it will calculate three things. What we really care about is betweenness centrality. And this is a way of describing the importance of a concept in our network for the overall network of tweets. So just click on OK, and then you'll see that it will generate a report over here that shows you the distribution of the values for betweenness centrality. Right? We don't really need to take note of this. I pretty much just close this right away. Next, we want to calculate modularity, and this is very important for text analysis. I have developed a framework where I am able to identify certain sub-themes or narratives in relation to the larger body of text. And this is determined using modularity class analysis. So what this does is it identifies communities or clusters of nodes that have very strong relationships with one another compared to the rest of the network. So, for example, if we were talking about Twitter or Facebook, the people that I would engage with on a frequent basis would be part of the same community as me or the same cluster. Whereas other people who tended to engage with one another more rather than with us would have their own cluster. And you can do the same thing also for words or pretty much anything you can put in a network. So words that tend to appear frequently alongside one another, in this case in a tweet from Donald Trump, would be in the same cluster, and then other words that appeared together more frequently would be in another cluster, and you would have a bunch of different clusters. And each of those clusters, in my theory, represents a narrative, and really that is the core of the kind of work that I'm trying to achieve with network analysis, is to understand the narratives that drive change in the world. Robert Shiller, the economist, put out a book about a couple years ago on what he called narrative economics. And what he said is that economists don't really invest enough time and effort in understanding how narratives shape the way the world works. And so just so we have a more complete picture when we try to, grapple with and solve all of the different problems that we have in the world, it's very important that we have a good handle on the narratives that people use to talk about these problems and try to work them out among themselves and eventually, hopefully, to solve them together. And so that's why I want to understand narratives. But back to modularity analysis. So what this does is it allows us to find the communities or the clusters of concepts that have strong relationships with one another. I usually set resolution down here to about zero point 0.6 or so, and that gives me a good amount of communities for a graph of this size with 480 nodes. I expect this to give me maybe 30 clusters. And if you did topic modeling using LDA, I would tend to find that between 20 to 30 topics would give you the best results. And so that's what I get with this kind of resolution as well. So it's comparable. So click on OK, and then we have 17 clusters. So in my theory, this means that we have 17 distinct sub-themes or narratives that we can identify here. So let's just click on close. And then, so we can start making sense of this blob. Let's do a bit of layout work. So first, let's put in the labels. So we want to know what these words actually are, right? Like that. And then it's still a mess, but you can see here that it's filled in some of these words already that Trump has been using in his tweets. Okay. Let me just see if I'm dropping frames here. No, we're not dropping any frames. So I'm it's pretty good. I hope that my lips are syncing up with my voice though. Anyway, back to Gephi. So we have the labels over here. Now we want to clean this up a bit. So the first thing I like to do is to color code the nodes by the cluster that they belong in. And this will allow us to more easily spot those singular narratives, which were clusters or communities of words that relate strongly with one another. So to do that, we click on this little palette over here, go to partition, and then select modularity class. And then this will allow you to apply different colors to these communities in the network. So let's go over here to generate, and then I probably want to color all 17 of those communities. So let's put in 17 here. And then let's go with pastel. Pastel sounds nice. So it will color our communities this way. And so it will be more easy for the analyst, me, to very quickly visually identify the individual clusters. So then click OK. Okay. And then you see here that there are a bunch of different percentages, and this shows you the size of those clusters. And this will make more sense a bit later on once we actually have cleaned up this mess over here. And click on apply. And then you can see that it has already colored some of the nodes, but the nodes are still too small, so it's still a bit hard to make sense of them. So what I like to do is to resize those nodes to reflect how important those concepts are. So I click on this little circle upon circle upon circle thing, go to ranking, and then select between the centrality. I've set these settings, so I usually just reuse them every time I use Gephi. And if you click on apply, you will see that there are some bigger nodes like this one over here and a lot of smaller ones. And the size of the node denotes how important the concept there is. Okay? It's still messy, so let's just spend a bit more time cleaning it up while we gather the tweets of Joe Biden. Next, we want to resize the size of the labels so that even the size of the labels themselves will tell us how important these concepts are to the network. So what we can do is, this is pretty good music, I have to say. I'm hoping it won't get copyright flagged by Facebook. I mean, look at these song titles and look at these artists. I doubt that they'll be actively trying to watch out for people streaming this music. There are a couple Kid Cudi songs here though. That's kind of weird. All right. Okay, now let's see. Let's also resize these nodes here between the centrality and there. So we can see right away that Biden is a pretty important concept in Trump's tweets. And I'm not surprised because they're going to go up against each other in the upcoming US elections. Then we have Ted over here. I'm assuming that's Ted Cruz. We have the Dems, who is always calling out in his tweets. We have Sen. I'm not sure. He's probably referring to some senator over there. But let's see what happens. I can see a peaceful protester, and then I can imagine just who he's referring to there. I see here Portland is probably related to that as well. So we have that, right? And now what we want to do is to lay this out so that all of the related concepts sort of bunch up alongside each other. And then we can say, hey, this community over here, this represents one narrative, and then this other community over here represents another narrative. So that's what we want to do. And I usually do use something like Yifanhu, which is a layout algorithm for network analysis. And what these algorithms do is they use different physics-based rules to sort of rearrange these nodes. So just to illustrate, if you click on run, it will sort of do a bunch of different things. It will move stuff around. And what you need to do is figure out the right settings here so that you end up with a graph that makes sense. This is a bit hard on the GPU, and so for this, I'm using my work laptop, which has a dedicated, I believe it's a 1650 Ti, which is pretty decent. No, is it a 16? It's a 1660 Ti, which is a pretty decent gaming GPU. And I don't think I'd be able to do this with anything less than that, to be honest. When I tried doing this on my Mac, it constantly crashed. But yeah, so that's not very useful for us, I think. We could also try something like Force Atlas, which is a gravity-based algorithm for doing layouts on networks. So if you click on that, you sometimes have to mess around. I actually am pretty familiar with the settings that I like to use here. But just to illustrate the different things that could happen, looks pretty interesting. Open Nord, I also often use this, so it does something like that. And then if you spread these things apart, you will see that the related concepts did sort of bunch together. But just today, I installed a plugin with a new layout algorithm called Circle Pack, and this is probably the most useful one I've found for identifying narrative clusters. So we can just open up the algorithm, and then as our first criteria for packing together these nodes, we can just choose modularity class. And if you recall, this is the statistic that determines which cluster the nodes belong to. So if you click on this, you can see right away that it's grouped all of the like-colored words together, which is pretty neat. So we can see here that all of these pink guys right here are strongly related with one another. All these green guys over here are also related with one another, and so on and so forth. It's a bit packed together, so what you can do next is to expand it. Like that. And then you can do, let's contract it. And then you can do you can do label adjust. You can do label adjust for your final algorithm. And then if you zoom in here, there you see it. So these, each of these clusters, which all have the same color, they represent a narrative, a single narrative or theme or sub-theme in Trump's tweets. And if you are familiar with the news surrounding Trump, then it will probably be a bit easier to make sense of this. What I usually do is combine this with LDA, with topic modeling and LDA, as well as social listening tools such as NodeXL. So of course, you could also check on the tweets here and see what the actual tweets contain. All right. So that's what we have there. And then if you go here to preview, you can lay out this graph and make it look a bit nicer. So maybe we can do, let's just use my default settings for now. So there's the graph. Let's try to use curve. Um, that's fine. It's not the nicest looking graph, I think, but it'll do. Should we use colors? Maybe source color. Let's make it a bit thicker. It's just so we can see the relationships a bit better. There. Let's go with 20. 3. I don't know why it's so thin. Rescale away. Yeah, we do need to rescale the weight. Let's go with 50 here. Curve it a bit. Just trying to make it look nice. I don't know why it's so gray. Wait, let me just try to fix that. Maybe let's go with a black background. Let's not do proportion size. I don't like the black background. Full curved. Let's just not use proportional size. I said don't rescale it. Okay. Let's go for maybe 3 and then use proportional size. Let's see what it's like. Yeah, these ones are just so outsized in their influence that they're having. That's why they have such big text over here. You know, we don't need to resize the text. Let's just do that. Yeah, let's just do that. Okay, so now we have this. And what we'll want to do is compare this network with Biden's net. And let's see what it looks like. Okay. All right, so let's see if Biden's tweets have finished downloading. Yep, so we also have 3,202 tweets from Joe Biden. And again, what we want to do is to figure out how his narratives, or at least the narratives contained in these 3,200 tweets, compare with those that were conveyed or that were communicated by Trump in his own tweets. And then maybe a bit later on, we can do the same for AOC and for Bernie Sanders, just as a little fun exercise. Let's copy this over to our corpus file for Biden. And you can see here that my laptop is starting to slow down. This software does take a bit of take a bit of a muscle, and it does wear out the system quite a bit. Okay, there we have it. And then let's save this as Joe Biden corpus. Joe Biden corpus. Okay. So again, we want to transform that corpus into a network that can be understood by Gephi, which is the software that we use for network analysis. So let's go back under the hood. We select again our list of stop words, which we will exclude from the analysis. Where is it? Desktop, datasheet, stop words. Okay, save, and then let's work on these tweets. Documents, Biden, Joe Biden corpus. We need to save it as a CSV first. Let's do that now. Yep, and so this is how we spend our Friday nights with the current pandemic. Okay. Let's do that again. Creative documents Biden corpus CSV. Here we go. Okay. Open that and then create the map. Shouldn't take very long. Why is it taking forever to load the stop words? Corpus. You know what? Just repeat that. It usually does not take that long, so I feel like something is going on there. Let's go under the hood, set the words to 500, select our stop words. This. Okay. Joe Biden. Joe Biden corpus. Okay. Create map. There we go. So usually it's just like that. It doesn't really take too long. And now we have a Joe Biden corpus.gml file over here, which we will now open in Gephi. And we will do the same thing that we did with Donald Trump. So let's open Joe Biden corpus.gml. We see here that there are 487 important concepts over here, as well as 10,790 connections between those different concepts. So, okay. Now, we can also, again, take a look at the words over here. I'm sure they're very different from Trump's words. Or maybe they're not, maybe they're not. Okay, so we see here stuff like love, fuel our campaign, downplay the threat, resilient American economy, beat Donald Trump, systemic racism, grassroots, really now, climate crisis, transform, a lot of liberal talk. Okay. So we have that, and then we want to do the same processing of all of that data in the same way that we did for Trump. So we are also going to end up with something like this. All right, so let's again calculate network diameter, which helps us determine the most important concepts in this network. There's the distribution if you care to know about that. And then we will determine the communities of related concepts by using modularity. So click on run. Let's use the same resolution of 0.6. It gave us 19 communities, which is also very similar to what we got with Trump. And then let's just do the same kind of layout. So we had 19. Let's go for pimp. Okay, apply that. I don't like those colors. Let me just change that. 19. Let's go for fancy light background. Okay, I prefer that. And then we resize the nodes again so that the most important concepts will have the biggest circles. Let's take a look at the labels themselves and resize those labels also to reflect how important they are. Mill, hey, Biden educator con. You know, this hey is probably not very, you probably can get rid of that just because it doesn't really contain a lot of meaning. Hey, let's get rid of that. What else? So you might need to do a bit of cleaning, but just to save time, I'll just delete hey and then we can go back to that. And then we will also do the same kind of layout. So we run that. That's a bit weird. Let me just... Okay, I selected the wrong one. It should be like that. Okay. So circle pack layout, we also do it by modularity class. There we go. Mill, I'm not sure what that's referring to, but we can find out. Mill, I'm curious. So let's go into the file that we have and just look for mill. Military families. Yeah, I think it's million. Okay. Yeah, so sometimes the software might, make a mistake like that. It's probably not supposed to be just mil. It's probably million or military. But we can live with that. Now let's do a couple expansions and then do label adjust. There. And now you have a clear view of these different narratives. So we have here talking about racism. This narrative over here. We have something here mentioning climate change and a clean energy economy. We have something here talking about war in the Middle East. We have Roe, which I'm guessing is about Roe versus Wade. So Roe mentioned in the also together with woman, LGBTQ, Wade. So yeah, it is Roe versus Wade. And then here he's mentioning Kamala Harris, who is his running mate. So it does sort of make sense. And this does tell us that everything, it's working as it should. And then let's just lay that out here as well. This is probably the nerdiest stream I've done so far. Why is it like that? Rescale, wait. Okay, that's good enough. I'm not gonna try to make it prettier than that. And then what I like to do is to export these charts at 16K resolution, but we don't really need to do that for now. I won't be posting these anywhere anyway. But they are interesting. You can see here. So again, this is the Trump network. Let's just use the same layout. This is the Trump network, and this is the Biden network. This is the Biden network. Okay. So now that we have that, maybe I will start gathering Bernie Sanders tweets just so we can compare him as well. Okay, let us import Bernie Sanders tweets. Wait, let's save this as Joe Biden first. Joe Biden Node XL. Node XL, open up another instance of that and start collecting Bernie Sanders tweets. I'm pretty sure if we played Steely Dan, it would get tagged. It would get flagged for copyright, so maybe not. Spiritual Beat Pals. Do you think that'll get tagged? Flagged? Anti-fascist black metal. I wonder what kind of techno playlists they have here. Tribal and Afro tech. I really wish they would put on the Caretaker's discography here. You can only get it on Bandcamp, I believe. Okay. Alright, so now that we have those, what do we want to do? Bernie Sanders. Here we go. Node XL Pro, import Twitter user network, Bernie Sanders. You know, we can put him together with AOC. I feel that they will be very similar. So let's put them together. Let's get their most recent 3,200 tweets. Let's just wait a while. Okay, so it's working. And let's let that gather tweets in the background while we do a bit of additional work on Trump and Biden. So the next thing that we could do is to see how much overlap exists between Trump and Biden's tweets in terms of the narratives and their words and phrases and concepts that they use. So there are a couple ways we could go about doing that. Maybe let's try... We can try to... it's hard when we have Node XL working. You can't really do much with Excel while it's doing all of this. I wanted to try to use... kind of want to use Excel to do something. But maybe while that's happening, let's just take a look at the different music choices we have. Should we listen to some Acid House? Oh, this one is a great label. Let's listen to this. This is a really good label. No, is that it? No, it's this one. It's this one. That's it before. I'm wondering if actually how this sounds on the stream. If everything sounds okay. And if anyone's actually interested in all of this weird data shit that we're doing. It's nice. Maybe a bit later we could stream some Dark Souls. I've been obsessed with yes. I love this label. Payment didn't go through. Lol. So this is also the first stream that I'm doing with Restream. I'm actually not sure how well it's working right now. I don't know what Twitch looks like. I don't know what my YouTube looks like. Hopefully it's all going okay. It's taking a while. Well, maybe while that's doing that, we could take a look at some of the tools that I use alongside Gephi for network analysis. I use something called PumpNet, which allows you to compare multiple networks in a GUI-based piece of software. So it looks like this. Where is that? All right, let's open this up. And I was having a lot of trouble with this with PumpNet the past couple of days. I made the mistake of moving my R library when I was trying to clear out space from my laptop. And after that, I just could not get it to work. But I spent the past couple of days trying to figure out what was wrong. I contacted the developer. He didn't really help me with this specific problem, but he did point me in the direction of two other new apps that his team has worked on over here. So we'll also take a look at this. We have NetConfer, which also allows the comparison of networks. So it says here it compares biological networks, and NetSets, it also says biological networks. But in fact, you could use these same tools for any kind of network. They don't have to be biological networks. And what they do is they show you how much overlap exists between different networks. So for example, just as a demonstration, if you go to the web app for NetSets, they have a bunch of sample analysis already set up there. This is some dope music. Still loading up our Sanders and AOC tweets. It usually takes about 10 to 15 minutes, I would say, to gather 3,000 tweets, which is not so bad. All right. So you can see some examples. Where are those examples? Let's look at some examples. I could have sworn there were some examples here. Maybe, oh, there are definitely some examples here. So let's go here first. And it pretty much does the same thing, but NetConfer has a few more tools that could be useful for network analysis. NetSets just gives you Venn diagrams, which shows you the degree of overlap between different networks. And NetConfer can do that, but it also gives you a bunch of other things on top of that. So as you can see here, all of their examples are pretty much biological networks. So you have microbial association networks. You have gene interactions. So if you want to look at, let's look at microbial association networks. So if you click on execute demo, let's hide this terminal over here. It's already done the work here, and then you can go to the dashboard. So it's compared these four things. Let's look at the details. Microbial association networks were generated using the data blah 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 blah. 4 broad Indian regions. Okay. I don't really understand that because I'm not a biologist, but let's just take a look at the kind of processing options that are available here. Okay, so there are a bunch of different things that you can do here. If you recall, they were looking at 4 different networks representing various regions in India, so you can select all of that. And then there are 5 different types of analysis that you can do for these networks. So you can analyze their similarity. Let's take a look at that. So it identifies nodes and edges which are commonly shared or exclusive to the selected network. So if you can imagine just going back to this network that we generated for Trump and Biden, we can actually see in a statistical way a kind of overlap that exists between this Biden network map of tweets and the Trump network map. And that will allow us to see whether they talk about some of the same things, whether they use the same kind of language to talk about those things, which is pretty interesting to see, among other things, of course. And then you can also identify and compare key nodes. So it selects what like an easy way to understand it are important nodes, that influential nodes within the network. And then you can do a bunch of other things, but I'm most interested in these two over here. So you can run that. Still gathering the tweets from Sanders. So you can run that and there. So it generates this Venn diagram over here. And you can see, for example, that this is the intersection between the east and north networks. So there are two edges. Let's look at the edges. There are two edges that are common to both the north and the east networks. And then if you click on that, you can see that it's these two things, these two kinds of microbes that are common to both of those regions. So you can do that. Then you can also search for individual nodes over here. You can filter stuff here and do different things. There are four which are common to all. There are four of these microbial associations that are common to all four of those regions. So that's what this does. Let's just see what this does over here. I just discovered this tool today. So I'm actually not super familiar with this. Go to visualizations dashboard. What does that do? Okay, so there are some visualizations we can do here. Intersection visualization, intersection common set of edges, exclusives union. This is super cool. I will definitely use this. The thing is, though, I could not get it to accept the CSV files that I had for some reason. I'm really not sure why. All right, let's try this out. See Mighty over there. Where's my phone? Okay, so here it generated a network map of the intersection between all four of those regions. So there aren't a lot. I would like to generate something similar for our Biden and Trump network, so hopefully we can get it to work. We just need to let this harvesting finish before we can work in Excel. Because I need to do some data cleaning in Excel before we bring it in here. Let's see what else we have here. Oh yeah, one thing that I've been listening to a lot lately has been Whitney's. They have this EP over here where they have some cover songs. They have, of course, here, this is originally Brian Eno and David Byrne. But the really good one is this here. This cover of Take Me Home Country Roads with Waxahachie. So let's listen to that here. There's a big chance that this will get flagged, but you know, it's the end of the video. Let's see. Such a good cover, and I love this song. Okay. Still gathering. But yeah, like I was saying, I need to do a bit of cleaning here, and that's why I've been reading up on index and match in Excel, which is super confusing to me, but I managed to get it to work maybe once earlier today. The other times I've messed up the formula somehow, but hopefully it'll work. Because the problem with Gephi is, if you look here in the data laboratory, so you have labels for each of these nodes, right? And of course, you need to know what word is associated with each of those nodes. In the edges table, by default, it will only have those ID numbers under source and target. It won't have the label. And if you export this table as a CSV, let's call it, what is this? This is Biden. Biden tweets CSV edges. So if you export this, it's comma, wait, for sure. Maybe not wait. Yeah, let's put in wait. All right. That's pretty good cover, right? Country Rocks. Oh, maybe the Quiet has put out a new playlist. Let's see. This is probably one of my favorite music publications. I don't really read a lot of these anymore. I used to read stuff like Pitchfork a lot before, but this kind of fallout from that habit. Let's see, Quietus 2020. Yes, so far maybe. Albums of the year 2020. So far, okay. All right, let's take a listen to this. I'm sure there's a lot of gnarly shit in here. Okay. Is it done? Not yet? God. Yeah, but anyway, this tool over here, CompNet, was developed by the same people who made NetConfer and NetSets. And maybe while we wait, let's just do a quick demonstration of NetSets and see what it can do for us. So if you have edge lists, so edge lists are, let me show you here. So edge lists are lists of those relationships between two nodes. So here I have a list of concepts for previous analysis that I did about Greenpeace. And we can see that these are the words that were related to one another, meaning they appeared alongside each other in pieces of content. And these numbers over here denote the weight of these relationships. So the more often those words were linked with one another, the higher their weight would be. And then we also have an edge list for social justice. So what I did here was I gathered like hundreds of articles related to different social justice topics. And then I did the same kind of from the Philippines specifically. And then I did the same kind of processing for that. And then I also have something here. It's called audience concepts, but really what this was I looked for Twitter users who wrote about the same topics, who posted about the same topics, and then gathered those tweets. And then what we can do just to demonstrate is you can actually plug that in here, and it will show you. Let's just select all of this. So audience. It's a pretty large network. It's probably gonna hang a little bit. Then we can do the same for, so for social justice. Oh, can't hear the music. Wonder why though. It's coming through an OBS. That's strange. It's definitely coming through an OBS. Can't Spotify be played through OBS? Hmm. Oh, okay, I know why. I need to add, it's not part of the scene. Silly of me. It's but then no, I don't need to add it to the scene. Uh, Okay, so I'm not sure if the music can be heard now. Hopefully it can. I added desktop audio as a source in this scene. I didn't think that would have been necessary, but then again, with my game streams, you probably don't need to add desktop audio because it just picks it up from the game capture itself. Yeah, so we moved over from Soviet Wave to the quietest albums of the year 2020, and I'm sure there's a lot of good shit in here. And most of it is pretty obscure, so there is a better chance of this not getting flagged on Facebook, where we are also streaming. Okay, so the Sanders and AOC tweets have not finished processing yet. It's been about 20 minutes now, so the server's working a bit slow. But while that's happening, we can play around with these other things. So let's just do a comparison between our social justice corpus and our corpus of Twitter users who posted about similar topics. Right, so you can see here, there are there is there's zero overlap between the two corp. That's a bit hard to believe though. Did I mess up somewhere? Yeah, that's strange. Still music's still not getting through. Well, we will have to just figure that out. Um, Probably for the next stream. I really just dusted off OBS again the past couple weeks or so after not streaming at all for about a year. So there might be some settings I need to fix. And it's a shame because this is pretty good music that we're listening to right now. So the processing of these Bernie Sanders and AOC tweets is taking forever, taking way longer than it did for Trump and Biden. I'm not really sure why. I would like to take a look at their tweets already. Well, we may as well export the files that we'll need to do the comparison. So, oh, not really sure if that's it, but there's something going on there. Okay, so let's export these Biden tweets over here and then the Trump tweets into an Edge file. Let's just call them. Oh no, that was Trump. That wasn't Biden. Trump. Okay. Now let's do the same for Biden, and then hopefully, once this Sanders and AOC thing is done, I can do a bit of data cleaning here in Excel, and then bring them into PumpNet, where we can actually compare. That's all of that data. Did it crash my Excel? I don't know. Okay, Biden tweets edge lists. All right. So that's pretty much ready to go. I just need to clean it up here before I bring it into CompNet. I might just have to cancel this Sanders and AOC thing if it's not gonna get going. Square Pusher. I didn't even know he had new music out. Still a bit of troubleshooting here on Reddit. Oh. Cipher. Yeah, something's happened here. Let me just cancel this so that we can at least clean up the Biden and Trump datasets. Okay. Now, what we need to do is to use the index match functions in Excel so that all of the labels here in the edges table will have the right ones from the nodes table. So we should also export the nodes. And all we really need is the ID and the label. Nodes. Trump. Here, let's see if we can sort this out. I need to copy this over to the edges file. Where the fuck is that? No, it's okay. Hopefully, this index and match thing will work. So what we need to do is to replace all of these numbers with these labels over here. And this doesn't always work as it should, so let's see. We want to match all of that. not very good with Excel. 10,529. Select all of this. Set match. NA. Fuck. Why didn't it work? Did that work? Let me just restart this thing. Back in a bit.